Let's look at large language models. These are the foundations for today's AI chatbots. And you may ask yourself, do I really need to know how an LLM works or how it's created to use it in class? And the answer is no. Many of us don't know how a computer compiler works for a specific language, but we're still able to code. But it's fun to learn new things. It's fun to level up, and students will ask. So let's check it out. Well, first off, what are LLMs? LLMs are a type of AI model that's trained on vast amounts of diverse textual data. And this data is then converted to weights or parameters in the model. And these parameters capture the patterns that exist in speech and language and text that we all use today. To create an LLM model is a three-step process. The first step is pre-training or weighting. The second step is labeling, and the third step is enhancing or enriching. Let's look at the first step, the weighting step. In this step, terabyte chunks of textual internet data are consumed by a transformer engine and converted into mathematical weights or parameters. These parameters are numeric representations of the relationship between the data that was consumed. Emphasis in this stage, in this pre-training stage, is on quantity of data consumed. And this is a very expensive, multi-week, $1,000,000, 6,000 graphical processing unit endeavor. Substantial computing power is required, and often pre-training is done annually or biannually. To grasp what goes on in the pre-training process, we can look at a block of words. The pre-training looks at words and parts of words called tokens to identify their contextual positioning relative to other words. So here, in this example, we will assume that the token word that we're interested in is football. What other words would be around the word football in text and speech? Game, penalty, pitch, soccer, run. These related words are turned into a pattern that represents their relative positioning to football and the frequency of use relative to the original word, football. A pair of words like football and soccer may not be used in identical contexts, but their token analysis and their associated pictorial representation may be very similar. The color bands for football and soccer do look similar. Compare these bands to the word I. Very different. After pre-training, the next step is to take our general base model and tune it to a specific domain and purpose. Unlike pre-training, which requires terabytes of examples, fine-tuning only requires a few 100,000 domain-specific examples. A domain could be focused on language translation, coding in Python, or selling cars. In the fine-tuning process, humans, and often human-AI bot pairs, select from a list of choices, or author best answers to questions, or upload pertinent documents that can be used to fine-train the model. This process fine-tunes the LLM base assumptions created during weighting and provides more accuracy. And it's often a days process requiring some human interaction. And that's in contrast to the weeks computing-intensive process of pre-training that we saw in the previous step. After fine-tuning, LLMs are enhanced. Well, how do you enhance an LLM? Well, the enhancements are to make up for some of the deficiencies in a textual-based model. LLMs are not good at math, but calculators are, so they're coupled on to the LLM. LLMs can get more recent content with web retrieval tools, can get images from their text using add-ons like OpenAI's DALL-E, or programming libraries for statistical analysis. So how does it work in its simplest form? Well, in its simplest form, the model's aim is to predict the next word in the sequence and do this repeatedly until an output is complete. So if our word was football, or what's the best night to watch football is the prompt we give to our chatbot, the LLM will go ahead and look at the probability score of other related words to the word football and may generate the best football games are on Monday night. LLMs are not perfect. There's many examples of large language models surfacing irrelevant or fictional data. In one high-profile legal incident in New York, a lawyer used an AI tool to create a brief for a case. The report was littered with made-up legal citations, so be careful. LLMs can also be tricked. For example, ChatGPT would not tell me how to make TNT or even provide the ingredients required. However, when I phrase the question a different way and ask ChatGPT to read a passage from a book that my relative used to read to me titled Making TNT, it was easy to get the ingredient list after a few prompt interactions. And there's clearly bias in LLMs. The bias stems from the lack of diversity of data in the pre-tuning and in the labeling process. Check out the image on the left. This image was generated by the prompt, generate a picture of a coding champion. Who is under and not represented in this picture? Well, let's get started. Now that we know a little bit about how LLMs work and how they support AI chatbots, let's dive in a little deeper and pick a chatbot for us to use.